Let us take the revision about rocks. Rocks are made up of two or more minerals. They are not crystals. Rocks are not crystals, but minerals are crystals. Igneous rocks. It is formed from melted rock when hardened. Now melted rock we get from interior of the earth. That why it is melting of what? Rocks and creates what? Magma. Magma rises but cools below the surface to become intrusive or plutonic igneous rocks. Now it happens due to why the melting is taking place, due to increased temperature in the interior of the earth and decreased pressure, and magma moves upwards because of its lower density, because pressure is now less, and high pressure from within, convectional current, as we have learned before, and it rises to the earth's surface where it is called lava. If it is solidifying within the earth's crust, it is called intrusive rock, and over the earth crust, then it is called extrusive igneous rock. This lava cools to make extrusive igneous rocks. They form the volcano also if it is too much thick, and melting of rock happens underground, as we have learnt in interior of the earth crust. Extrusive volcanic rocks forms fine grain crystals, whereas intrusive has large grain crystals like granite. Because of molten materials spreads over a large area, so it cools down relatively faster. That is extrusive igneous material. Whereas intrusive takes more time to get cooled. The magma's temperature is more than lava, that is interior part of the volcano. Here is the magma chamber, and whatever the magma's different formation is taking place, then they take long time to get cooled, and so they are crystalline. Whereas the lava which is flowing out, it is coming in contact with the atmosphere and flowing a larger area, and that's why it is getting cooled soon and it is not having large grain crystals. It is fine grain crystals. Igneous rocks, extrusive area above the earth crust, intrusive below the earth crust. Above the earth crust we have lava plateau because of the successive flows of lava. Next, we are having parasitic cones, volcanic formation, or we can have the neck of the volcano or pipe of the volcano depending on the solidification. And intrusive one, we have facholith, we have laccolith, we have locolith, seal, dike, batholith, and stalks. Now let us see batholith. Batholith which gets solidified above the magma chamber itself. Then it is called batholith. A huge one, it pushes up. Next one is coming stalks. Stalks are generally batholiths but of smaller dimension. Dikes more or less vertical, like we are having here one dike, more or less vertical, and sometimes it is not properly vertical, but no, neither it is horizontal. It is crossing through the stratas, not in one strata at all. Locolith, it is saucer shaped locoliths we get. Over here we are getting saucer shaped locoliths, and then we have laccolith, flat bottom and convex upwards. Over here we are getting convex upwards and flat bottom. We have facholith. Facholith here actually don't mix up with the lopolith and lacolith. When the intrusion and solidification of magma in the anticline and syncline of the sedimentary stratus, that is crest and through, then it is called facholith. It is continuous. Here is also one facholith we are getting. Next, because most igneous rocks are composed of silicate materials, the chemical classification based on the percentage of silica, presence of silica in the rock. It is compound. The subdivision of igneous rocks according to this presence of silica are acidic, intermediate, basic, and ultra basic. Acidic is rich in silica like granite. Acidic magmas are very viscous, thick and sticky, erupt explosively of pyroclastic flows. Intermediate, below that, it is not that much acidic, and comparatively it is having the percentage of silica will be less, and then it is coming for basic gabbro and basalt. They are poor in silica. Then they are also rich in metals like magnesium, iron, and often described as mafic. Magnesium and ferrous together mafic. And then we have basic magmas are very thin, flowing easily over the ground. Generally, they form the lava plateaus, and much more basic if we get, then they will flow a larger area than basic, then it will be called ultra basic. Difference between acidic igneous rocks and basic igneous rocks. High content of silica, more than or nearly 80%, whereas basic igneous rocks poor in silica. Acidic magma cools faster, does not flow and spread far away, whereas basic magma cools fast slowly and flows and spread far away. Here, acidic igneous rocks makes volcanic mountains, whereas basic igneous rocks makes lava plateaus like Deccan Trap. Then acidic igneous rocks have lesser content of heavier minerals like iron and magnesium, whereas basic has more content of heavier minerals like iron and magnesium. Acid's color will be lighter, whereas basic will be darker. Acidic igneous rocks will be hard, compact, massive, resistant to weathering, whereas basic igneous rocks will not be that much hard and they can be weathered relatively easily. Acid igneous rocks we have example like granite, quartz, feldspar, and basic igneous rocks basalt, gabbro, dolerite.